Hi everyone, welcome back to my channel. In this lesson, we are to learn trigonometry. Before we start, let's just look at the three sides of a right-angled triangle. So here you have the right angle here, and it's symbolized by this symbol, and opposes the right angle. You have this green side, and is called the hypotenuse. And this hypotenuse is the longer side of a right-angled triangle. And we denote the length of the hypotenuse as c. And you have two other sides. So the two other sides, we call them the legs because these two sides made up the right angle. So we give the length of each leg as a and b. Let's introduce the first theorem we have. Is called the Pythagoras Theorem. So Pythagoras Theorem wants to tell you that given a right-angled triangle and opposes the right angle, we have the longest length of the right-angled triangle that is labeled in green and is known as the hypotenuse, and it has the length c. So I want to use the length of the hypotenuse and create a square. So I believe I should get a square like this, and I denote the area of the square as c squared. And remember that, I have two other sides of the right angle triangle. They are the legs. They are A and B, respectively. And I would also like to draw a square each using the length of each leg. And I suppose you have these two squares here. And let me label the area of each square as A squared and B squared. And if we are to look at the three squares here, which square would you think is the biggest and has the greatest area? And I believe is c squared, the one in green, because you use the longest length of the right angle triangle to create a square. So definitely you should get the greatest area. And this is what Pythagoras theorem wants to tell us, that the area of the largest square, c squared, is equal to the sum of the two smaller squares using the length of the legs. You have a squared plus b squared. A squared plus b squared is equal to c squared is the mathematical expression of Pythagoras theorem, where c represents the longer side of a right-angled triangle and a and b are the legs of a right-angled triangle. Moving on, we are to apply the Pythagoras theorem to find the third length of a right-angled triangle. Let's recall the Pythagoras theorem. A squared plus b squared is equal to c squared. And now let's identify our a, b, and c. So I believe your a should be 3, b is 4, and c is x is an unknown. We are to solve for x. And now the next step is to solve by substituting each variable into the equation. So a, you have 3. In place of a, you are to put 3. In place of b, you are to put 4. And in place of c, you are to put x. We are to simplify the equation. On the left, 3 squared should give you 9, plus 4 squared should give you 16. On the right, x squared, it remains as x squared. 9 plus 16 should give you 25, equal to x squared. And now we just want the value of x, not x squared. We are to remove the power 2 by applying square root to both sides of the equation. By taking the principal root of 25, I believe you should get your final answer as 5. X is equal to 5. The square root and the power 2 eliminates, leaving you the x. And now you have found that the length of the hypotenuse is 5, given the length of 2 legs. We have to look at another situation where the hypotenuse is given, and given one of the legs, you are to find the length of the other. Again, you have the right angle. This is a right angle triangle, and we are to apply Pythagoras Theorem to determine the third side. And we are to apply Pythagoras Theorem to determine the length of the third side. Let's recall the formula. A squared plus b squared is equal to c squared. And let's identify our a, b, and c. So a, we do not know, so x. B, we have 5. And c, we have 13. You are required to substitute each into the equation. A, in place of a, you put x, so x squared. In place of b, you put 5 squared. In place of c, you put 13 squared. You are required to simplify the expression. X squared remain as x squared plus 25 equal to 169. And we are to make x the subject, so we are to minus 25 on both sides. I believe your left-hand side, the plus 25 and minus 25 gets eliminated, leaving you x squared. On the right, 169 minus 25 will give you 144. And now we are to remove the power 2 and get the length. So we apply the inverse operation, that is square root. The left-hand side, your power 2 and square roots gets eliminated, leaving you the x. On the right, if you take the principal square root, that should give you 12. And now we have successfully determined the length of the red side is 12. If you like this video, don't forget to subscribe.